Hello everyone. Today I will be presenting how migration to Kubernetes impacts your developers. Hope you will enjoy this topic, and let's start. My name is Oleg Verhovsy. I'm CTO and co-founder of Codefresh. Thank you for joining. So a little bit about Codefresh. Codefresh is CI/CD as a service optimized for Kubernetes. We have native support for Helm and Kubernetes deployment, tens of integrations and hundreds of pipeline steps, full Helm release management, DevOps insights, and happy 50K accounts that using Codefresh. So a little bit about what we're going to talk about. First of all, we will discuss about different patterns for Kubernetes adoption. Kubernetes become a very popular orchestration platform, and every cloud native application, or almost every cloud native application, consider using it. And so we will discuss how companies is usually doing it, which challenges it can bring to developers and other stakeholders, and what solution we propose based on an observation of hundreds of customers. So let's start. So again, Kubernetes, I don't need to say how popular it is, and there is a good reason. It's mature, open source that basically help you to manage, orchestrate, scale your application. It's portable, so you can install it on every cloud and even a data center, local machine. All this put Kubernetes is almost standard for managing and orchestrating cloud native application. And now I will share a few observations that we have when assisting to many customers to migrate to Kubernetes, or just learn from their experience when we actually discuss with them about it. So interesting fact that together with adopting to Kubernetes, usually teams are splitting their legacy monolith to microservice-based application, and it's because the microservice-based application perfectly fits the philosophy of Kubernetes. Many company workloads are moving from on-prem to cloud, private to public. When you migrate to Kubernetes, most of your teams are affected. It's not only one department, operation or DevOps. It's almost every stakeholder that involved in application release lifecycle. We will elaborate why and how to and what challenges they can meet. All processes, so most of processes are affected as well. You develop differently, your CI/CD looks, or there are different requirements, and obviously operation and security aspects affected as well. In addition, usually when considering Kubernetes or actively migrating to Kubernetes, companies take into account security, operational, and cost aspects, but many times forget about development practices and CI/CD. And this can definitely harm their success when migrating to Kubernetes, and again, we will see why. This is basically summarizing what I already said. So how actually organization decide about the adoption strategy? We saw three patterns, and I want to touch each one of them. So the first one is organization expects that everybody becomes an expert on Kubernetes. Kubernetes is everybody should be able to operate, define, monitor, deploy to Kubernetes, and this is great. However, the challenge here is basically make sure that everybody gain this expertise, and the extra knowledge is relevant for everybody, and it's not distract the developers from their main goal. The second approach is actually opposite. With this approach, DevOps actually, organization actually abstract the development organization from everything related to Kubernetes, and it's kind of black box approach. So developers only focused on their components, and then the CI/CD systems, additional components that the DevOps should build, basically operating the whole build, test, and deploy phases. However, we found that this approach is successful only in very limited amount of companies, because it's require significant effort of DevOps to build different tools that basically provide all those capabilities. In addition, DevOps become very fast the bottleneck, and everybody, every change, every configuration, every activity that require some more deep analysis require DevOps involvement. So we think that this approach is hardly be successful in a majority of the companies. And the last one is actually most common and most practical one, where developers are exposed to Kubernetes. They have knowledge, but the heavy lifting operation on Kubernetes and infrastructure management are done by DevOps. So this is kind of control complexity approach, and I think this is the not only the most common, but I think the most successful one. So let's take this approach and see which challenges still are relevant when adopting the Kubernetes. Developer feedback loop is now longer. Surprising, right? Everything should be automated, well defined, declarative, and still developer feedback loop is longer, and it means that he's more and more surprised. His developers need to wait more and more time till he actually understands that his code is okay. And the main reason for this is, there are a few reasons from my point of view. First of all, the development environment many times stays behind than staging and productions that actually move to Kubernetes. And in many cases, development environment looks using non-Kubernetes tools like Docker Compose or just Docker, or even running on the host. And it means that the first feedback you can see on staging, it's very hard to build integration environment where you can make it available for every team member or even for team. It's again means that you cannot easily get your feedback and run your code in a real environment. The second challenge we already touched it. It's Kubernetes is complex system and it's not only complex system, it's changing, evolving, and its ecosystem is almost exponentially growing. You see many amazing projects that are coming and integrated into Kubernetes. And in order to gain expertise, you need to invest it, and it's sometimes non-trivial for developers that has obviously additional tasks. CI/CD is built on top of legacy tools, and maybe good for monoliths or for non-Kubernetes environments, are less relevant right now. The deployments are faster, are much more scalable. the number of components are growing constantly, and you need to create stable, manageable, and reusable CI/CD system that can help. It's in most cases require changes on existing CI/CD solution, and this is obviously the area where Codefresh is focusing. Traceability between code and actual deployment artifacts. So today, when you basically deploy to Kubernetes, you need to package your code, usually with Docker, as Docker image, then add to it some deployment manifests, and finally deploy to Kubernetes. Those steps, with the dynamic nature of Kubernetes deployment, it's replicated and sometimes running on different nodes, etc., makes very hard to correlate between the change and the actual code. The need for visibility is very important, and that's why we implemented this feature in Codefresh. Complex deployment strategies like canary deployment and patterns like feature flags even add more complexity, because you can find multiple versions of the service deployed in production, and the ability to understand where exactly the problem is and reproduce it and fix sometimes non-trivial at all. So let's discuss the long developer feedback loop. I'm describing here the very classical Git flow, and however, I will separate it, the feedback loop for three stages. One is your feedback that you are getting on your feature branch, basically implemented by CI system. And as we mentioned, CI system should be fast, reliable to provide such feedback. Pull request, or after it merged to master, the feedback that you're getting is basically from CD systems that notify you that your deployment was successful, and if not, why, and what action item. Make sure that you are always in a predictable state. And the last but not least, the workflow, the feedback loop, when you're actually working on your local environment. Even there, you want to get as much feedback as you can, even before you push your code or run in CI. We believe that CI and CD system should be one to provide such comprehensive feedback, and this is how we are building our product. I think the one of main items that organization should implement in order to resolve this long feedback loop problem is to implement on-demand environments. On-demand environments or dynamic environments means that you can constantly, automatically create full environment, full or partial environment of your distributed application. These capabilities is critical for not only for getting fast feedback for developer during debugging application. It's provide you the ability to share and collaborate with your colleagues. Use it to avoid some bad hard coding practices where something is expecting to work on one environment and suddenly doesn't work on the other. And of course, your CI/CD system can use dynamic environment for integration test, and it's basically one of important validation areas that you can add for your CI/CD system. So I think that on-demand environments is very important to successfully shorten the feedback loop. However, how to implement it? And here our recommendation is, first of all, define automated and repeatable deployment architecture for deployment configuration for your application. This is the minimal requirement. So you can install your application different environment with a minimal manual or with no manual work and getting the same result. Then you can create different bundles of your microservice-based application. So you, for example, you can create some dev bundles that will include some subset of services. You can create maybe a component or bundles per use case, but basically you don't need to replicate anytime a whole application. And of course, the what can make it even more successful or valuable is implementing service mesh. So basically your several versions of your service can coexist in one Kubernetes environment. And it means that you can always test your latest service with stable environment and without affecting the stable scenarios. This is obviously very important capabilities. By implementing this, you're getting super important asset to provide fast and valuable feedback for your development organization. Let's talk about Kubernetes compatible development environments. That for me, it's very important to reduce feedback loop as well. As I mentioned, even when you working locally, you need feedback. You need to get some confidence and see how things working on native Kubernetes environment. So you need to be able to provide to your developer, or developer should have dedicated Kubernetes cluster, whether locally or remotely installed. Developer can get feedback even before pushing to Git and running CI. So it's very fast and very short feedback. Developer can execute integration scenario at some degree. And there are good tools that can facilitate this development workflow, like Octeto, Scaffold, Draft, and others. To implement a Kubernetes compatible development environment, I found 3 approaches. One is actually, I call it port forwarding, means you're always working locally on your component, but those tools like Telepress and Kube Forward that I recently tested is basically forwarding the or proxying the network, so you can basically access the services that deploy on Kubernetes environment, on remote Kubernetes environment, and provide you the flexibility to test almost every scenario, so every integration scenarios from your local machine by using your ID. That it's actually great. I think it's useful. However, underneath it's every tool defines some different proxy configuration, port forwarding, etc. And for those developers that like, visibility of how things works, maybe it's less. In addition, it's still a remote server. The other approach is actually use workflow, dev workflow tools. It's a new category of tools that basically create kind of a short build, test, deploy workflow that focusing on development flow. So they basically synchronizing your code to with some cluster. And the last category is actually dev remote environment as a service. Again, Octeto is something that I introduced recently sounds very promising. There is Jenkins 6 DevPods and some other options. Again, it's basically provision some namespace with specific configuration isolated by using Kubernetes RBAC and provide a nice interface of how to control different aspects of Kubernetes without actually be making administration of Kubernetes. In addition, at least some of those tools facilitating the synchronization scenario mentioned in the second approach and provide you the whole nice experience. If you ask me, I definitely think that for local day-to-day environment, the second option is most useful. It's easy to understand, easy to manage. It's deployed to your local Kubernetes, so it's very fast, or you can use it with local Kubernetes. Where the first option is nice when you want to mimic real scenario, for example, investigating some very complex bugs that can be reproduced only on production environment. Let's briefly discuss the advantages of using local Kubernetes for development versus remote one. So the local is installed on your machine. You're using your tools, completely isolated, and it's very fast inner loop. This is those pros. The cons, it's resource intensive. Sometimes you cannot mimic some infrastructure aspects for some cases, and usually you manually set up your environment because it's isolated from CI or any automated central system in your organization. When using remote, actually you have required capacity and scalability. Your development environment is much closer to production, and it can be provisioned automatically using some automation process. The cons, it's more expensive, especially if you are duplicating the whole environment. Debugging and tracing requires tooling and not trivial. And network interruption, network latency can harm the total experience of day-to-day work. So again, I think that if you can use local for some use cases, it's great, it's fast. However, the option to create a remote cluster for some specific use cases is a great advantage as well. So it's kind of complementary and not only this or that. This is basically a slide that Octeto CEO shared with me, that kind of describing the concept of synchronizing the code within the namespace that created automatically for specific use case, specific developer, specific team on demand, and you can manage multiple namespaces for different needs. Let's talk about problem that I call it extra things the developer needs to know. So together with tons of manifest that now developers is exposed in case it comes, it expected from him to manage them. In addition to manifest for every entity that part of configuration of your service, deployment configuration. Sometimes it's those are templates, so you need to so it's even less readable. So all this is definitely not pleasant at all. I think that the solution is clearly separate between the configuration for infrastructure components, storage, network, autoscale, ingress, etc., and your applicative one. Group your manifest. Okay, you can use Helm, you can use Customize and Git, depends on the approach, but you need to be able to group manifest that associated with deployment of your service. Inherit application configuration from common settings. When I create or adding a new service, most of defaults are applicable to my service as well. I don't need to create it again and again. Reusable CI/CD. This is something that a developer is aware for it as well, because now he's responsible, at least at some degree, for release life cycle of his service. So I think that organization, this is patterns that we definitely recommend, will create reusable pipeline based on phase. For example, when you are working on your feature branch, this is the proposed workflow. When you're deploying to masters, this is when you want to create release candidate or promote some version of your service, you can use different pipeline, and multiple services can use the same pipeline. This is provide much more manageable system, where as developers that already exposed or expected to know the CI/CD will successfully reuse things rather will create. And I already mentioned that I personally prefer YAML over templates because it's much more readable and it's very hard to understand the templates. Let's talk about something that I think is very important to resolve when you're adopting Kubernetes and obviously pushing to continuous deployment or even more complex deployment patterns. And I call it deployment confidence. I think that developer confidence to make safe deployment is critical. Even if code is not has bugs or issue, the process itself should be consistent and stable. Means you can clearly understand what current state of your deployment, if it's failed or passed. Visibility that your code was successfully shipped to production. You need to understand and see and be 100% sure that your code currently running in production. And this visibility should be implemented. I will show how we did it at Codefresh. And the last but not least, if something happened, you need to simple, I call it one button click, ability to rollback, and bring the system to previous state. I think obviously it's not all requirement for developer confidence, but I think that the conceptually those are most important. And now you can see how we implemented the traceability between service that run in Kubernetes. So you can see this Kubernetes service, you can see the image, a Docker image behind that actually running inside the pods. On the right screen, on right part of the screen, you can see the which version of code associated with this image, and you can always navigate to specific change. So this connection between code to what is deployed is very important, and I think it's definitely should be the pattern. Doesn't matter which tool you are using or how you implement it, but the principle, I think it's important and add for confidence of developers and people that deploy the code. And the last, I think that debugging and tracing of Kubernetes is complex, and it's complex because the nature of cloud native application is dynamic. The pods come and go. IP may change. There is no definity where you can find your pod on different machines. Everything is distributed, and in order to successfully be able to reproduce issue, resolve it in a consistent way, I think that, again, the easy provision of dynamic environment is important. It means that you can reproduce the environment very fast and start working with the access. Again, it's not SSH as a popular quote is that kubectl is a new SSH, but still it's something that provide you the isolated environment to test. Or there are interesting tools and services like remote debugger or Kubernetes debugger, the company Rockout, etc., that helps you to actually debug the live system with in non-intrusive way. So I think it's helpful as well. So this is basically our observation of which challenges around a release lifecycle and specifically for developers can be introduced by organization when adopting Kubernetes. We propose a few approaches to shorten feedback loop, implement Kubernetes native environment, help to developer to minimize the number of manifests that they need to work, and of course the how to make the developer confidence around deployment much higher. I hope you will find it's useful. Feel free to share your thoughts, provide your feedback. We're constantly learning, and it definitely can, we will really appreciate any feedback. Thank you very much. And thank you for Alcid for a great initiative. And now those are related resources that we use during this presentation. Feel free to check those projects and companies. They're really cool. We'll be happy to get your question. Feel free to reach out to us on the Kubernetes CTO forum Slack channel. We will be there. In addition, I want to thank you to our developer advocate, Kostis Kapilonis, and our solution architect, Guy Slaton, that helped me with this presentation. And special thank for CEO of Acteto, Ramiro, that shared with me some interesting insight about the challenges of developers and introduced me his great product. So thank you, Ramiro. Thank you very much. I hope you enjoy, and waiting for your question on Slack channel.